Okay, so 8.5, angles of elevation and angles of depression. What's the difference? Well, elevation is when you're looking up, depression when you're looking down. So you're looking, when you normally look, you look horizontal. So when you're looking up at an aircraft in the sky, you're looking up as an elevation. And then think of it from the pilot's point of view. He too looks horizontal. He's looking out the window straight forward. But when he looks down, he's looking at an angle of depression. What's the difference? You'll see in a few minutes that they are both the same thing. So here's angles of elevation. Okay, so this, if you take this as you normally look horizontal. Well, the moment you start looking up, there's your angle of elevation. All right, and then the same thing, because like I said to you a few minutes ago, you normally look horizontal. So the moment you look up, you've got an angle of elevation. Okay, well then imagine that you then stand on the top of a hill. You're still looking horizontal, so you're looking that way, and if you're looking down, you're now looking at angle of depression. Well, look at what you've got. You've actually got a pair of parallel lines and your transversal, so you know that alternate interior angles are equal. So if this angle here, if your angle of elevation is 40 degrees, then you know also that your angle of depression is also 40 degrees, or the inside part of your angle of depression is 40 degrees. Okay. And here's a typical type of question, all right. And as you can see, you get a lot of it is in story form. Okay, it's very rare that you get angles of elevation and depression as a diagram, sometimes, but not very often. Okay. And again, first thing you've got to do is target the angle. You've been told the angle is 38 degrees. There's your target. What have you been given? Well, the height of the turret is the opposite side. Okay, and you're finding AC, which is the adjacent side. So straight away, you're looking for a tangent question. Okay, so either quote the formula as it is in SOHCAHTOA or rearrange the formula. It's entirely up to you, whichever way you go. But again, look at the question. All right, the question says to the nearest foot, so it's 236 feet. Okay, so here's question number one. What have you been given on your diagram? Well, here's your angle. There's your target. The 10 feet is opposite, and it's asking you to find the length of the base of the ramp. That's this guy, so that's the adjacent. So straight away, you've got a tan question. There's your target. Okay, which is it, sine, cos, or tan? Well, this is a tan question. So tan of theta is equal to opposite over the adjacent, and theta stands for angle. Okay, so tan 20 degrees is equal to 10 over whatever the adjacent is. So let's just rearrange that. Okay, so the adjacent is equal to 10 divided by tan 20. Okay, so the adjacent is going to equal 27.5 feet. Okay, it doesn't give you a degree of accuracy, so normally 1 decimal place is good enough. Okay, so here's example 2. Now we're looking at an angle depression. Well, look, like I was saying, okay, the pilot of the helicopter is looking horizontal, but his angle of depression is 42. Well, notice that the 42 is not inside the triangle. Okay, you need an angle that's inside of a triangle. Well, if you go the X route as being horizontal to the pilot's eye, here's the internal angle, alternate interior. So again, look, you'll see that this is 42, the same as the angle of depression. Again, you've got your target angle, 42. The diver is at 18 feet, that's the opposite, and it's asking you to find DC, so therefore you've got the adjacent. So again, it's a tan question. First and foremost, find out which one it is. Okay, so here's question number 2. Look, a fan is seated in the upper deck of a stadium 200 feet away from the home plate. If the angle of depression to the field is 62, what is the height of the fan? Quick thing to do, draw a diagram. Okay, you know your fan, you're standing up there. You're 200 feet away. So this is the base plate. Okay, this is the fan. Okay, what do we know? The angle of depression is 62. So that's the same as this guy, which is also 62. Don't forget you need the angle inside. He's 200 feet away. Well, it's not talking about the horizontal, it's talking about the diagonal from here. So this is 200 feet, and it's asking you for the height, which is x. So now we've got, here's your target angle, the 200, the 62 degrees, okay? X is opposite, and you've been given the hypotenuse. Which one uses that? It's sine. So this is a sine question, all right? So quote the formula again. Sine theta, opposite over the hypotenuse. All right, so you've got sine 62 is equal to, in this case I'm going to put x over 200. Okay, rearrange, so it's going to be x equals 200 sine 62. Okay, and you're going to finish up with 176.6. Okay, again, it doesn't ask for a angle, degree of accuracy, so 1 decimal place is sufficient. All right, you've got Annabelle and Rich. You don't know the distance from the directly underneath the ball to Rich, but you know his angle of elevation is 50 feet. Annabelle is 5 feet further on than him, and she's got an angle of 40 degrees. And what it's asking you to find, look, is the height of it, okay, which is your x. Okay, so just basically, because they've used x, the distance from directly underneath or the right angle to Rich, I'm going to put that as y. Okay, just purely and simply of the letters they've used. Okay, so now you've got to do two parts of a solving system. So I'm going to start with Rich. Okay, x is opposite the angle, the y is adjacent. So it's a tangent question. All right, so just quote the formula for a minute. So tan theta is equal to opposite over the adjacent. All right, so that's the basic formula. So now we're using Rich, remember, so it's going to be tan 50 degrees is equal to, now I'm going to put the letters in place of what they've got, but even though they've given us x, so it's x over y. Okay, so tan 50 is equal to x over y. We don't know what x is, we don't know what y is, now we're going to find it, but it's a long method. All right. Well, we know in the end of it, we need to find x. So what we've got to do is rearrange this. Okay, so what we've got now is x is going to be equal to tan 50 times whatever y is. Does everybody get that? Okay, so that's the first part of what is basically going to be a solving system. Okay, so now let's have a look at Annabelle. Well, what do we know about Annabelle? Okay, it's still a tangent question, so it's still going to be tan is opposite over the adjacent. Okay, but now we know that Annabelle is tan 40 degrees. Okay, opposite we still don't know, so we've got to put x. But now we can't put y, because that's the distance from the ball, directly under the ball to Rich. Well, she's an extra 5 feet, so it's actually going to be y plus 5. Does everybody get that a little bit?
Wait, I'm confused about the y.
Let's do the same again. We're going to rearrange it. It's going to be y plus 5 because we're multiplying it, and that's going to be our tan 40, and that will also equal x. So as you can see, what we're trying to do is build up an expression of x equals something for Mike and x equals something for Annabelle. All right, so it's y plus 5, tan 40 will equal x. Well, distribute it along. So you've got tan 40y, okay, plus 5 times tan 40, and that will give us x. Okay, so now we've actually got an expression for Annabelle. Annabelle. Okay, so we've got one for Mike to whatever x equals. Now we've got one for Annabelle equals. Okay, so what have we got? We've got this y tan 40, okay, plus 5 times tan 40. So that's going to equal 50 times y. Sorry, got that wrong, hang on a minute. tan 50 times y. Just a minute. So that's tan 50 y. All right, or y tan 50. So now I'm going to subtract the y tan 40 from both sides. So on the left-hand side, I'm left with 5 times tan 40 is going to equal tan 50 y and tan 40 y. Hang on a bit, subtract tan 40 y.
So do you get tan?
Okay.
Tan.
Going to do now, we're actually going to factor out the y. So we've got our 5 tan 40 on the left, that's still not changed. Okay, I'm factoring out the y on the left, on the right hand side, so that's going to leave us with tan 50 minus tan 40. Okay, so now in other words we can find the distance of y, because now we can actually work out what 5 times tan 40 is and what tan 50 take away tan 40 is. Now please don't make the mistake that students make of thinking, well, if it's tan 50 take away tan 40, I can just do tan 10.
Nope.
No, doesn't work like that. All right, so let's go to page 11. 5 times tan 50, 40, divided by tan 50 minus tan 40.
No, I thought it was time.
Is it multiply or minus?
I can't tell.
Minus.
Alright.
Hang on, what's 5 tan 40?
I rounded to the tenths place, is that fine?
Okay,
4.2.
okay. And tan 50 take away tan 40 is?
0.35.
Okay, 0.35. So,
You
okay.
get 12.
And then you've got 12. Okay, so you know the distance from the ball, directly under the ball to wherever Mike is 12 feet.
It's almost taken up.
We've got a tan question. We've got tan 50, because now we're doing Mike, and we're going to times that by our 12. Or you can go to Annabelle, which is tan 40,
Let's not do that.
and you can multiply that by 17, because she's 5 feet further. Okay? If you do either, this is Mike, the first one is tan 50 times 12, Annabelle is tan 40 times 17, you get the same answer, which is 12 point something? 14.3 feet.
In the answer key it says it's 14.2.
Well, because we're rounding it up. All right.